We are now going to learn it formally. So we are going to call it tree traversals. Traversing a data structure is a very important thing that you have to do whenever you are learning a data structure. It is very easy to traverse an array. It is very easy to traverse a stack, just keep popping on and on and on. Same for queue, keep popping from one end. And same for, I think, linked list also, just keep moving to the next pointer, right? So that is with respect to linear data structure. The thing with linear data structure is that if a data structure is, let's say, found in one line, then the moment you moved from here to here, you never have to worry about coming back here. Yes or no? The moment you left a node, no need to come back because everything else is lying in your right hand side. So keep moving in right hand side. Do not worry about coming to back because you will get nothing from there. So this is a very, very important point, right? So I can use a for loop and a very, very simple logic to traverse any linear data structure, okay? But when you talk about hierarchical data structure like trees, so as we have already seen, let's say you have something like this, 5, 7, 9, this is what you have, let's say. Then at a particular time, you have two choices. You can either go here or you can go here. Again, you can relate whenever, when we were learning recursion, I told you very clearly that whenever you see that you are at a particular state and there are multiple transitions that you can make, okay, then because at a time you can make only one transition, so you can call the second transition and that second transition will be executed when the first transition is completed. So how that happens via recursion. And how recursion does it? It creates a call stack, okay, and that call stack is that once you move from a node to the other node, so once you move from a node to another node, then you basically, once let's say that entire node is explored, you come back here and then you are able to venture on to the next node, right? So that is the key thing about recursion. So if I have to traverse a tree, let's say I haven't taught you anything till now. Can you actually traverse a tree? Traversing a tree is simple. The meaning of traversing a tree is you print me all the values of the nodes. And you can print me all the values of the nodes in any order. I don't want the order to be specific. Can you all do that on your own, guys? Somehow printing all the values of a node. It's very easy, right? So simple enough that whenever you are here, then you make a call for this. When you make a call for this, ensure that you have also made a call for this. Because if you don't make a call for this, once this is over, and let's say you return back here, then how do you ensure that you go in this tree? Okay. So there are many ways in which we can perform the traversals of a tree. There are three of them which are very popular, and the first of them is Preorder Traversal. What is the meaning of Preorder Traversal? So the traversals that we are going to learn right now, they see tree in a manner which is as simple as possible. Simplest manner. And what is the simplest manner? Root, left subtree and right subtree. This is how any of these traversals see this tree. And what do they do is, because they know that tree is a recursive data structure, any subtree is also a tree. So what they will do is, when I talk about preorder will first print the root and then we'll do the job for left subtree and then we'll do the job for right subtree. Okay, what do I mean by that is, if I am performing preorder traversal, then this can be thought of as a recursive function. Okay, so if it can work on the entire tree, it can work on any other subtree also, right? Now while working on this big entire tree, it will first print this 5 and then it will call the function for this much part, and when this is over, then it will call the function for this much part. This is how it goes on and on and on. And how left subtree is to be printed? The same way the entire tree was printed, your left subtree would also be printed. Okay, so just to take an example, what I can say is something like this. So first you would print this 5 and then you will call the function on your left subtree, which is this. Let's keep them small, a bit small. Yeah, just this much. You have 7, 6, 4. And when this thing is printed, then the call for this would be made. And it is very important to make this call followed by this call, right? Otherwise you will not be able to travel there. See, this is a great thing that recursion does for us. You can't just move from here to here and then here to here, because the moment you have moved from here to here, and let's say you did not touch this, you will never be able to touch this again, because the only way to touch this is from any node that is lying above it. Once you have come here, there is no way you can touch this. So you have to call for this part as well as this part, right? So yeah, so now this is printed, so the game of this is over. Now again here, the first thing that would be done is you would first print the root, and then you would call the function for the left subtree, which is the 6, which has a null null, and then you call for 4, which again has a null null, and then this thing will be taken care of later on, right? Now when you come to this, again first you print the root, which is 6, and then you call for left child. Left child is null, so nothing would happen because empty tree doesn't contain anything. So the moment the call is for null, it means that that entire tree is empty, so do not do anything, just return. The same thing will happen for this also. Now again, this was also like this, so you print the root, call for left child, it is null, nothing happens, call for right child, null, nothing happens. And now again here, you first print the root, and then call for your left child, and then call for your right child. You know your right child is null, so nothing would happen there, so I am not going to even draw that. Now again here, you first print the root, which is 9, and then call for left child, which is null, so nothing will happen, and then call for right. No, this entire thing will be printed as just 1, because left is also null and right is also null. So this is the pre-order representation of this particular tree. So if somebody gives you a tree in an interview, let's say your interviewer gives you a sample tree by drawing it on a piece of paper and asks you that, hey, print me the pre-order traversal. Can you do that without performing any dry run or without having to run the code or anything? Can you do that? Yes, that's easy, right? You just, follow this rule, root, then recurse on this, then recurse on this, okay? So let me test it out quickly for you. Let's say you have something like 1, 2. Yes, can you quickly print for this? What will be the pre-order form of this? Is that what everyone is getting? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes, that is perfect, right? So if you do whatever I have done, you would get this, right? So pre-order is also called as depth first search. Now we will learn depth first search in detail while we explore graphs, but this is depth first search because this moves in a deep manner, okay? So let's say it started from here. So first it prints this, then comes here, prints this, then comes here. Because you always first call left and calls right, so its tendency will be to always go in left if there is a subtree there. So again it will go there. So after 3 it will print 4. Now if you consider this subtree, 3 is printed, left subtree is printed, so now it will embark on the right subtree. So now it will print 5. There is no left, it will not go there. There is right, yes, it will go there and it will print 6. So now what happens, let's say this is printed, so control comes here. So this is the subtree for which the root is also printed, left subtree and right subtree are printed. So now this will terminate, and now control comes here, this will also terminate, and now the control goes here, then it comes here, then it comes here, then here, and then here. So this moves in depth, right, while trying to explore the tree, okay. This also means one very, very interesting thing, that if let's say you just think of it on your own. Let's say I'm going to define a term level. This is level 0. These nodes are at level 1. These nodes are at level 2. And these nodes are at level 3. So if there are multiple nodes at the same level, which node will be printed in the DFS traversal or pre-order traversal? Can I say it will be the leftmost node? Yes. Why? Because the very nature of pre-order traversal is like that. When it goes in depth, it ensures that first it calls for left child and then it calls for right child. See, these are the part of this subtree, right? And this will not be explored until unless this is done. And if you take a look at, so 9 and 10 have to come after 4 and 5. And now again, if you talk about 4 and 5, 4 is part of this left subtree and 5 is part of this right subtree. So whenever you are here, you first call for left and then for right. So if you take any particular level, any level, the first node to be printed of that level would be the leftmost node, and last node to be printed of that level would be the rightmost node. So how is the preorder traversal going to look like? If you take a look, you can just write a simple method, recursive method. It will be void because it doesn't have to return anything, it just prints, and it takes the root of the subtree which is to be printed. So first it will take the root of entire tree, okay, and then so when should I terminate? Whenever I see that my root is null, that means that is an empty tree, so please do not make recursive calls, just terminate, so that you can return to your parent, and then that parent will, let's say, you made a call here, so I should terminate here so that control comes back here, and now it can just invoke its right child, okay, right subtree. So what is the first thing that you do? First you print out the value stored in root, and then you make a preorder call to root left, and then you make a preorder call for root right. This is how preorder traversal looks like. Can you detect the output if I interchange these two? If I put this line first and this line later, would you be able to predict the output, guys? Yes or no? You can do that, right? The only difference now is that instead of first calling your left child, you will first call your right child. So it means that first root will be printed, and then entire right subtree will be printed, and then entire left subtree will be printed. That is the difference which is going to come. And this difference will happen for every subtrees that you will keep on decomposing on and on and on. So you guys can try doing that on your own. So I think, what can we call that? We can call that as reverse preorder. I don't know the name for that, but you can think of it like that. So still all the nodes are going to be printed, just the order is going to be different. Okay, another important thing, very, very important thing is Inorder Traversal. So Inorder Traversal, as the name says, that the root will be in between the left and right subtree. So first you will print the entire right subtree, the entire left subtree, and then you will print the root, and then you will print the entire right subtree. So it's just like that. So let's say there is a 1 here, and then there are some things here, and then there are some things here. So first these things would be printed, and then this one will be printed, and then these things would be printed. So such kind of printing where any root is lying in between the entire left and entire right is called as the Inorder Traversal, and this thing is true for any node, okay. So this is what the Inorder Traversal is, okay. So what changes will come? Before we even talk about changes, can you tell me the output for this tree itself? Inorder Traversal of this tree. Can you guys type it out quickly? I think the nodes are still visible, right? They are just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes, 2 should be there at first, isn't it, guys? So it's important to understand. It's very, very important to understand that 2 has to be there first, right? Because if you take a look here again, if you called for this entire tree, this 1 will be printed in between the left subtree and the right subtree. And let me draw the left subtree. It is this. And let me draw the right subtree. It is this. So this is to be printed later. Before this will be printed. So the reason I am writing like this is to never forget it, that this 1 was printed before the printing of this has to be done. I repeat it. The reason I write it like this is because it makes my mind very clear that, hey, before these things are printed, this is printed, okay. Now again, same thing will happen over here. First you print the entire left subtree. The left subtree here is empty, which is null, so that will not get printed. And then you print the root, and after printing the root, you print the entire right subtree, which is 3, 4, 5, 6. See, there was left subtree also, which was null, but nothing is going to get printed, so I am not doing anything with that, right? And then after this entire thing, 1 comes, and then that thing will come. I will catch that up later. Now again, when you talk about this, what will be the first thing that will be printed? The root, which is 3, okay. So first you will print this 3, which is your root, and then the left subtree, which is 4, will come here, and then the right subtree, which is 5, 6, will come here, and then this 1, and then that, right? Now again, this 4 has left subtree as null, right subtree as null, so none of them will be printed, so it is 4, 2, 4, 3, and then here again, First you will print your left subtree, which is null, so nothing gets printed, and then you print 5, and then you print 6, and then you print 1, and then the same thing would happen for this also. You have a 7 here, 7, and then the left subtree is null, right? So first you call for left subtree, which is null, so nothing gets printed. Then the root, which is 7, gets printed, and then you recursively call for 8, 9, 10, 11. Now again here, first you call for left subtree, okay? So first you call for 9, and then in between 8 will come, and after that you will print the right subtree, which is 10, 11. So again, if you come here, first left subtree, which is 11, will get printed, and then the right subtree, which is 10. Then the root, which is 10, and the right subtree of 10 was null, so nothing gets printed. So this is your order for in-order traversal. It is very, very important traversal. Okay, so let's wait here for a while, and you guys tell me on your own that what will be the time complexity of these both traversals if there are n nodes. It will just be order n, right? Because the moment you are there at a node, there is just order 1 work that you do. If that node is a leaf node, you return, which is order 1, and if that is not a leaf node, then you print it and then you make the further calls, right? And if it was in order, then the only difference that would come is that this print process will come in between now. So if this is in order, this print process where you print root value will come in between these two. So first there is a call for left subtree, and then print the root, and then call for the right subtree. And what is the space complexity? Would anyone mind talking about that here? Order of height, okay? Will there be an extra space or not? You tell me that. It is a recursive code, so definitely recursion will have its own call stack, recursive stack, and recursive stack will have its own size. Now what will be the maximum size of recursive stack? You tell me that. Height of the tree, okay? Will it be height of the tree for both the traversals or just for preorder? What do you feel? So guys, if you take a look here, what happens is that when recursion works, recursion always explores one branch, then only it moves on to some other branch, this or this, whatsoever it is. And you terminate the moment you see that a root is null. So if let's say it was any damn root, let's say this was the root where you reached and it was null, that means before coming here, you would have been here, right? You cannot call this from this or this or this or this, right? So before coming here, you would have been here. Similarly, before coming here, you would have been here. Before here, you would have been here. So this would have been the recursive call stack, right? So because you are terminating at null in both the approaches, the stack of the recursion would be nothing but a root to leaf path in both the approaches. And the maximum root to leaf path is something which is called as height. So whatever would be the height, that would be the maximum size of stack at any point of time. So this would be the maximum space complexity no matter which of these two approaches you are using. So let us learn more about it. So now see what is going to happen here. So if I am talking about a third kind of traversal, that is a post-order traversal. What are your thoughts about post-order traversal? What would happen in post-order traversal? The only thing that would change would be that the printing process of the root will happen in the end. So it will say that, hey, first print me entire left subtree, then print me entire right subtree, and then you print me the root. This is how it looks like. So this is the meaning of post order. Post means in the end, okay? So the root is to be printed in the end. That is the only thing, right? So can you guys determine let me give you something like this. What will be the post order traversal of this? Can you do that really quickly? First entire left, then entire right, and then the root. So how is that going to look like? My root will be printed in the end. Before that root, my entire right subtree is to be printed recursively. And before that, my entire left subtree is to be printed recursively. Now again, if I talk about this, so first my entire left subtree, which is 3, null, and then my entire right subtree, and then after that this root. Now again, if I talk about this, first it will be my left subtree, and then my right subtree, which is null, so it will not get printed, and then 5, and then this one. Now you know what will happen to them. Left subtree and right subtree are null, so they will not get printed, so it will be 3, 4, 2, 6, 5, 1. With respect to code, the only change that will come would be that this thing will now come over here.